Week 5, lesson 3. All right, so let's suppose that there's a die and we throw it for 60 times, okay? So in a perfect world, how many times would you expect it to land on a 6? Well, because there's 6 sides and you're expecting it to be perfect and very, very, very fair, you would expect that it would land 10 times on each side, right? 10 times on 1, 10 times on 2, 10 times on 3, etc. Okay, that's called theoretical probability, right? Again, in a perfect world. But here's some actual results, right? So it didn't land 10 times on every number. Some of them were a little bit less, a couple of them were a little bit more, right? Make sense? So let's find the probability of x equaling 1. Okay, well, you can see right here, it happened 9 times out of the 60 tosses. Probability of 2 is the same. 3, and don't feel like you have to reduce these right now. Okay, so right now I just kind of want you to see that these are all over 60 because we tossed the dice 60 times. Okay, so now when it's asking you to find the mean, right? Remember this notation for mean? That means I know that I'm going to be dividing by 60, but do I want to have to write out this 1 9 times, right? Do I want to put 1 plus 1 plus 1 plus, right? No, I really, really don't want to write that all out. So instead, we're going to multiply, right? We're going to say, all right, it's 1 9 times, and it's 2 9 times, and it's 3 12 times, it's 4 8 times, 5 11 times, and 6 also 11 times. And if you break out your calculator, this should come out to be 3.6. Okay, now this is kind of hard to wrap your head around, but go with me here. This is what's called the expected value. Okay, the expected value. And I know when you toss the dice, you're never going to get this decimal, right? You're only going to get the integers. It's just what's called the expected value. All right, now, as the number of trials increases, okay, so like instead of just tossing this thing 60 times, let's say we toss it 60 million times. Then what's going to happen is the experimental probability will approach the theoretical probability, meaning that these probabilities down here will be 1/6 each, all right? And again, we're talking an exorbitant amount of die tossing for these numbers to come out exactly like this. Okay, so there's some new notation for you. This is what's called the expected value. This is the Greek letter mu. It's used for expected notation. And this computation is literally the same as the last one. It's going to be 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6, etc. And if you put that in your handy dandy calculator, you'll get an expected value of 3.5. Right, so our small data set over here gave us a pretty close approximation, but with much, much, much larger data, this is the actual expected value.